Hello, so we're back on Asteroids. We've got a ship appearing on the screen and it just moves ever so basically across the screen like so, and now we need to actually get it moving sensibly that the user can actually control it. So from last lesson we had the ship class here. That's everything to do with the user's ship. We've then got things setting everything up, so creating the ship, creating Pygame, and then our game loop, which is just handling all the events, just setting the background color, doing any updates which are needed on all the sprites, then drawing them, then updating the screen. As you can see, I've added comments in, but nothing else has changed. Okay, the first thing which I'll note is we got the position self.x and self.x plus 1, so we're using that to change the center. Now for completeness, would be nice if we also had position y. We can if we want change that to y, and so that means that we're using that variable for the entire position. We've not got a random 200 stuck in there, and we really should change these ones as well. So throughout the code we're referencing the position of the ship by self.x and self.y, not just the 100 and 200. Granted, they start at 100 and 200, but they can both change. So now, because we're updating the x and the y, we should see the ship moving diagonally. There we go. So it went down that way, which shows us that that is 0, 0 up here. So when you're displaying the screen, it's going to start here and then display as much as it needs to down there. Okay, so what we need to do is when we update it and we modify the position, we don't do it just based on adding one to each time. Instead, we actually take into account what the user has pressed. So to do that, we need to get all of the key presses. Now we can use this code here and then say if the event type is key down, and if that key is forward, then change this. That does get rather more complicated, and then you're handling all the key down events and all the key up events and have to keep track of it all. The easiest way for a program like this is just getting all of the keys which are currently pressed. So that command will get a list of all the keys which are currently being pressed, and then we can just say if keys pygame.k up print you're pressing up. Now if we just run that, check that it works, so it's loaded. Now whenever I press the up arrow, you see it spamming the command line. Okay, so we got it doing up. Actually we don't want it to print anything, we'll just pass for now. Pass doesn't do anything, it just stops it erroring out that there's nothing in the if statement. So that would cause an error. That doesn't. It doesn't do anything else. So when I create a function or a class or some if statements and I've not got as far as actually writing some code for them yet, I often just put in pass, that way you know that it won't error out. So that will work, it just won't do much. So we've got the x plus 1. What we can do just to get something working, there we go. So we're increasing the x by 1 and the y by 1 when right and down are pressed. Give that a go and the ship should stay there. We press the right arrow, it moves that way, press the down arrow, it moves that way. Awesome. we can quite easily get the up to go -1 and the left to go -1 on the X, and that will work. But we've got some basic movement. We've got it so it actually moves around this character on the screen. Not how we want it, but it's a good start. Okay, so let's talk about movement. So when we're moving a rocket ship, we can have it so that when we move it, it just goes forward, and then when you let go, it stops dead. But I think it would be a lot cooler to have it so it sort of glides to a halt. In order to do this, we need a thrust value. So the speed that is actually moving forward. We can call this all sorts of things. I'm sure physicists may have issues with my namings, but hey. So thrust starts off at 0, and then we can say that when the up arrow is pressed, self.thrust is increased by 1. And then when the down arrow is pressed, instead of this, we have self.thrust goes down by 1. This is just a shorthand way of saying self.thrust equals self.thrust minus 1. Okay, so we got the thrust, and the thrust will change as we hold down the keys. So now we need to use that thrust value to figure out where it should be. Now, how can we do that? Well, what we can do is we can just update self .x and do that for y as well. This isn't our final solution, this is just getting something working. Let's have a look, see what that does. Ooh, maybe that was a bit too much. Let's have a look at it now. See if that's still a bit fast, but hey. So that is setting the thrust. So it moves all over the place. Okay, so let's have a look at how we can get turning working. Now it's going to be a similar concept to having the self.thrust, but where thrust tends to be forwards and backwards, we're having a rotation value. And we'll start at 0. But then when you press left or right, we'll want rotation to increase or decrease by 1. So whoops, change that to -1. Okay, so rotation, as we hold down the left or right, the rotation speed will increase. Now the direction is what way is it going to face. Now I want the rotation as the rotation speed, so that would be if you start rotation, it will carry on. And let's have a direction, much like the x and y coordinates. Self.direction, and that's going to be the amount of degrees we're facing. So turning 360 would obviously be in a complete circle. Okay, so the direction is going to be changing by the rotation amount. Now that could be positive or negative, so if you add those numbers together, that's going to come out fairly accurate. Let's have a quick look to see what this is doing. Not a lot. Okay, so the left and right keys aren't really doing much. The forward and backwards are still doing the thrust. Now this is happening because we're not actually rotating the image. So in order to rotate the image, what we need to do is recalculate the image every time it's moved. Now there's a transform section and the function, conveniently enough, called rotate, and you need to tell it what you want to rotate. So we just want to rotate the image, and we're changing it, rotating it by direction. Now this seems like it should work, but hopefully we can see a rather interesting issue. Now that's gone all sorts of weird. Okay, so the reason that's changed and gone all sorts of weird is because we're taking an image, rotating it ever so slightly, and then saving that as a new image, then rotating that ever so slightly. Now each time you rotate an image, it's going to lose quality. If you think of, say, a 5x5 grid and draw a straight line down the middle of the grid, or even a plus, now rotate that slightly, the new line isn't going to be a straight line. It's going to be an all sorts of jagged line. It's going to try and keep it as accurate as you can, but it's not going to be ideal. Now when you turn that again, it's just going to make that new one even worse. So what we need is to save the image as an original image. So now we're not going to be rotating the image, we're going to always be rotating this original good quality image. And yes, it may degrade when we rotate it once, but the next time we rotate it, we're using the original image again. So hopefully that looks a bit neater. There we go. Now the one thing I notice when I'm zooming around in space is that the thrust and the rotation aren't infinite. They don't just carry on forever. So there tends to be a bit of slowdown. So in order to slow the rotation, I'm going to divide it by about 1.05, and that should just cause it to slow down slightly. And we can do the same with the thrust. And this is just going to make sure that it doesn't carry on ridiculously. There we go, we can see that it's zipping around, but it's slowing down and stopping. Okay, probably need to make some of these values a bit smaller. Okay, so we got the ship rotating and we got the ship moving. Now unfortunately the ship isn't actually moving in the right direction yet. And that's because we are using the same thrust and applying that thrust to the x and y coordinates equally. What we need to be doing is saying, okay, if the rotation is that direction, straight across, then the thrust just applies to the x coordinate and nothing on the y coordinate. If the rotation is downwards or upwards, then the thrust only applies to the y coordinates and not the x coordinates. And vary between them for everything in between. Now, if you think about it, you're starting to get triangles, and you're starting to get flashbacks of GCSE maths and trigonometry, and things like SOHCAHTOA. So we have the x is the adjacent, the thrust is the hypotenuse, and the y is the opposite, and then we've got the angle in there. Now, we could go through theory for quite some time, but allow me to give you a couple of nicer lines. So self.x plus equals self.thrust times by the cosine, so hypotenuse times by cos of the angle. And then very similar for y, but this is using sine. Now I'm using a negative direction there just so it turns in the right way. So let's have a look at this. See, whoops, I've still got the okay, that's a math is not defined. So I'm using the math module there. Here we go. So when I do the arrow keys, it turns, and then when I press forwards, ooh. So that's moving fairly sensibly. However, if I get back on the screen, it appears that it believes rockets go sideways. So all we need to do to that is make sure that whenever we draw the ship, we draw it 90 degrees across. There we go. So now we should have a rocket. That's not right. So that's the forward button, so not plus 90 degrees, minus 90 degrees. So let's have a quick look. There we go, much better. And there we have our rocket moving fairly sensibly. The next thing we need to look at is how to get it not vanishing off the screen. We want it looping around, so when we come off this side of the screen, it comes back on the other side. So we'll need to look at how we can do that. Okay, so getting it to come from one side of the screen to the other. If we have a look at, that's the screen. Up here we have 0, 0. We have 800 pixels across, we have 600 pixels down. We started off the rocket at that position, so 100 by 200, and so it draws it quite happily in that spot. Now if we subtract from the x-coordinate, it then becomes 0 by 200. If we keep subtracting, it will quite happily try and draw the ship at minus 100, 200, which isn't terribly useful if we're trying to play the game. Instead, if the ship moves off that edge, what we wanted to do is reappear there. And likewise, if the ship goes off that edge, it should then reappear there. And similar with the y coordinates. It's a lot easier if you work with one coordinate at a time, get that working, then it's easy to transfer those skills over to the other coordinate. Okay, so let's have a look at the code again. We've got self.x and self.y. Those are the key things which we're changing. Throughout all of this, we're doing all sorts of weird and wonderful maths just to change the x and y coordinates and the direction it's facing. We've got the screen, which is set up at 800 by 600. When we've got a variable like this which is set for the entire program, it's not something which will change during the program. It may change for the next run, yeah, but it's not changing through the program. That's where constants are useful. So we can say screen x is going to be 800, and then we can change that to screen x. It's traditional to have block caps for constants. Then you know if you see something which is in block caps, for example, that you know it's a constant. So we've got screen x. We can also have screen y as 600. At the moment they're chucked in the middle of nowhere. Let's move them up to the top. Now as soon as you open this file, you can see I've got a couple of constants there, which is the size of the screen. That means we can reuse those values throughout the program for other decision making, and therefore if we change it here, everything will be the same. We don't have to search through the entire program for wherever we've written 800 and hope that that's only for the screen size. So where would we need the screen size? Well, quick tip, you're going to be doing this yourself, but I'm just trying to give a few pointers. If we look back at our screen, if we're looking purely on the x-coordinate, that is 0, that is 800, aka screen x. So you can check to see if the x-coordinate of the ship is greater than 800 or less than 0, and then modify it accordingly so it appears in the correct place. That's the essence. So I'd highly recommend having those globals in there. Then you can use those globals in here and have a bit of code. There we go. So that is something for you to do. Okay, so just to quickly run over everything which we've covered so far in this video. We've got our ship with an x and a y coordinate. It's got a direction which it's facing. It's got a thrust, so how much momentum does it have going forward or backwards. It's got a rotation, so how much momentum does it have going sideways. We're loading the image as an original image, as to keep the original in good nick, and making sure that we're not modifying that. we're then altering the thrust or the rotation based on the key presses, and we're just making sure they entropy appropriately so that they decrease to 0, so the thrust isn't constant forever. We're then calculating the changes to the x and y based on the thrust and the direction it's facing. So just to do a bit of a diagram for that, if we've got the ship here and we're going in that direction, essentially it's drawing a right angled triangle and calculating what the x and the y change will be if this is going to be our thrust. So we'll work on the thrust here. This is always going to be the same amount. We're always moving the same distance. It's just the amount that we're changing on the x and the y will be different. For example, if we're going that direction, you're going more on the x than you are on the y. The right angle triangle. Whereas if you're going in that direction, you're obviously doing a lot more on the y than you are the x, based on a ship there or there. Okay, so in order to get that, we can say that we've got this angle, which is our direction, and then we can just do some trigonometry, say, okay, we know what the thrust is, we know what the direction is, therefore what's the adjacent, therefore what is the opposite. And that's all we're doing with this bit of maths. We know what the thrust is, we know what the angle of the direction is, so therefore we can do the maths to figure out what the x, what we're adding to the x and what we're adding to the y. Then you're making sure that it comes off one side of the screen, comes back on the other. And then we're making sure the rotation of the ship, which is being taken from the original image, so it's not going to get mangled, is rotated the correct amount, minus 90, so it's not going sideways, we're actually pointing in the correct direction. And then we're recentering the rectangle that we're drawing it in. I don't think we actually changed anything on this, so we're all good. Okay, get that all sorted, and we shall look at adding asteroids in the next video. Good luck.